G'day, welcome to the Tech Math channel. What we're going to be having a look at in this video is linear equations. Moreover, we are going to look at the linear equation. Linear equations, as you'll remember, these are equations that if you were to plot the x and y values on a graph, on an axis, you will end up with a nice straight line. So what is the linear equation and why is it so handy? I'll show you right now. Now the linear equation is this one here. You've probably seen this one or a variation thereof. It looks like this. Y equals mx plus b, or you might have seen y equals mx plus c, or a variation thereof. And pretty much all linear equations can be brought back to this particular equation. And once you know how to look at this equation and analyse it, what the little m and the b mean here, you can tell a whole lot about this particular linear equation just by looking at the equation itself. So I'm going to give you an example of this. So I'm going to use an example to explain this. And the example I'm going to use is this one here. Y equals 2x plus 3. Okay, so we'll work out first off the x, y values and that sort of deal. We'll put them on a graph, and then I'll show you a couple of key things that you can tell off the equation itself. So first off, if we were to do this, let's put in the x values. X is minus 3, so minus 3 times 2 is minus 6, plus 3 is minus 3. And then we have x is minus 2 times 2 is minus 4, plus 3 is minus 1. And then we have x is minus 1 times 2 is minus 2, plus 3 is positive 1. And we're going up by 2's each time. You're probably going to notice that already, okay? So 0 times 2 is 0, plus 3 is 3. And this one's going to be 5, this one will be 7, and this one will be 9. And I can plot these on a graph, okay? So on the axes I've got over here, minus 3 and minus 3. We have minus 2 on the x, and we have minus 1 on the y. So minus 2 on the x and minus 1 on the y. We have minus 1 and positive 1. Okay, that's up here. We have 0. On the 0, we cross at 3. At the value of 1, we have 5. On x is 5. And at 2, we have 7. And I'm not even going to be able to fit that there. But you're going to see we have a nice straight line here, yeah? Hence the word linear equation once again. But without having to plot it each time, you're going to notice a couple of things. First off, you might notice that where x equals 0, where we cross this y-axis here, is this number here. This here is known as the Y-Intercept. This is the value where x equals 0 and therefore what y equals. And it's pretty simple because if you made x equals 0, it will say what y equals here. If x equals 0, y is going to be equal to 3. Okay, and that's a fairly common feature here. And this b here is the Y-Intercept. The other thing we can see here is this number here, this coefficient here. And what that does is that tells us how steep the graph is. Okay, so you're going to notice this 2 here. Well, as we go across 1, we're going up each time here by 2. We're going positive 2 each time. Positive 2, positive 2, positive 2. And as we go across 1 here, we go up 2. This is the gradient. This is known as the gradient. I'll put that in a different colour. Okay, this one here is the gradient. And what that means, quite often we think about this being the rise over the run. And the way I think about this is this goes across, it rises 2 for every 1 that it runs across. Okay, and that's what this here tells us. The other thing it tells us also is you'll notice if it had been a negative 2 that this graph would go downwards. So that's the linear equation here, this one here, and it tells us a whole bunch of things. So let's have a look at a couple of examples just to see how handy this particular equation is. Okay, so say we had this particular graph here, y equals x plus 4. Now the first thing we can tell is that if x equals 0, the y-intercept here is at 4. Okay, so where x equals 0 at this particular point here, y is equal to 4. So the graph crosses over this particular point here. The other thing we can see is the gradient here. The gradient in front of this x here, which is going to be equal to 1. Okay, this is 1x plus 4. So this means the rise over the run, it means for every one we go across, we go up 1. And we go across 1, we go up 1. Okay, so we go across 1 to 1. On x equals 1, we're going to be at 5 here. And we go across to 2, we're going to be at 6. And we go across to 3, we're going to be at 7. Moreover, we go back this way, we're going to be going down a similar sort of thing. So we're going to have this graph that looks like this. Okay, a nice straight line that looks like this. Okay, anyway, what about we have a look at another one? Say we had a graph which was this one, y equals minus 2x take away 3. Now, first thing, we can tell where this y-intercept is, because where x equals 0, y is equal to negative 3. Okay? Straight away, we can see that straight away. The other thing we can see is the gradient. Okay? This is the rise over the run. Now, this minus here tells us that instead of going up this way, this graph is going to be going down. It's going to be going down too. So this means the rise over the run, which is a way I like to think about this, is going to be, it's going to go down to for every one it goes across. So it's going to go down to for every one it goes across. It's going to go down to for the next one it goes across. We're going to go this way. This one's going to be here. This one's going to be, it's going to go up here, so like this. And we're going to end up with a line that looks like this. Okay? Now, that's just off having the equation there without drawing up any little tables or anything like that. How handy is that, right? Now, in future videos, we are going to show you how to be even more precise with these graphs and a couple of other little things you can do. But that's the linear equation. Probably really one of the most important things you remember if you are doing linear equations. Okay, so hopefully that video was of some help. Okay, we'll see you next time.